Good morning, everybody. I am Dr. S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I am going to discuss about a key and important topic under probability and statistics. It is discrete and continuous random variable. This is the main topic under probability and statistics. So already in the previous ones we have discussed about some random variables. Those random variables are two types. They are discrete random variable and continuous random variable. What is discrete random variable? Discrete random variable, it gives a perfect count in a particular way. It gives a numerical value. In continuous random variable, it gives the value in some range, in some interval. So the value of the random variable lies in some interval in continuous random variable. That is the main difference between discrete random variable and continuous random variable. So let us take some examples for discrete random variable. Under discrete random variables, we can take while we flip a coin, coming head. What is the probability? 50%, means 1/2 numerical value. Coming tail, 50% chance is there, means 1/2. Half of that 1/2 is the numerical value. Like that, these are while we will drop some these dice. In dice, what are the chances coming? 1, 2, 3, 4, 5, 6. See, there are 6 possible events are there. So the probability for coming each number is 1/6. They are equally likely events. Like that, for coming 4 is also 1/6. So like that, each value has a specific numerical value. So all these examples come under discrete random variable. Now, what are the examples for continuous random variable? For continuous random variable, measuring height, measuring weight, all this comes under measuring height, weight, they come under continuous random variable. Why? Well, because if we measure that height comes, suppose 162 centimeters. After that, it may go to 162.5. It depends upon where they are standing and how they are measuring. All these things also play important role. So their height and weight, they lie between some range, some interval. That's why they come under continuous random variable. So here let us see what is continuous random variable. A continuous random variable is a random variable that can take on a continuum of values, where height, weight, whether 161, 162, 163, 161, 162.3, 162.4, where they are standing, it depends upon that variation. Continuum. So continuous random variable is a random variable that can take on a continuum of values. In other words, a random variable is said to be continuous if it assumes a value that falls between a particular interval. So the value in continuous random variable, values fall in a particular interval. Continuous random variables are used to denote measurements such as height, weight, time, etc. So, height, weight, time, these all lie between some interval, some range. So, these are best examples for continuous random variables. The area under a density curve is used to represent a continuous random variable. The area under a density curve is used to represent a continuous random variable. Means, suppose now the area lying between x-axis and this curve, it comes under continuous random variable. In this article, we will learn about the definition of a continuous random variable, its mean, expectation is a little bit same as mean, variance, types, and associated examples. What is a continuous random variable? A continuous random variable and a discrete random variable are the two types of random variables. A random variable is a variable whose value depends on all the possible outcomes of an experiment. A continuous random variable is defined over a range of values, while a discrete random variable is defined at an exact value, as we discussed earlier. It gives a numerical value, exact value, in discrete random variable. Whereas in continuous random variable, its value lies in a range of values. Continuous random variable definition. A continuous random variable can be defined as a random variable that can take on an infinite number of possible values. Due to this, the probability that a continuous random variable will take on an exact value is 0. Why? Because it is continuous function. That's why it will take on an exact value 0. Next, the cumulative distribution function. What is meant by cumulative? Cumulative means it should have some boundaries, lower bound, upper bound. That function may go to somewhere. It is upper bound. It is lower bound. So, in between that function varies. That is called cumulative. The cumulative distribution function and the probability density function. The cumulative distribution function and the probability density function are used to describe the characteristics of a continuous random variable. These two functions will describe the characteristics of a continuous random variable. Continuous random variable examples, let us see. Suppose the probability density function of a continuous random variable x is given by 4x cube, where x belongs to closed interval 0, 1. This is one example we are taking. The probability that x takes on a value between 1 by 2 and 1 needs to be determined. Suppose this can be done by integrating 4x cube between 1 by 2 and 1. Thus, the required probability is 4x cube. Here, integral of 4x cube under the limits 1 by 2 and 1. Here, what is the integral? 4 into x cube integral is what? X power 4 by 4. Now, taking the limits between 1 by 2 and 1. Upper limit minus lower limit. If you take upper limit minus lower limit, what will happen? 1 minus x to the power 4 means 1 to the power 4 means 1 minus lower limit 1 by 2 to the power 4 means what? 1 by 16. So it will become 1 minus 1 by 16. So it is 16 minus 1, 15 by 16. That's why it came. So we are determining from in a particular range. That is the main feature of this continuous random variable. Now let us see some formulae about this continuous random variable. The probability density function and the cumulative distribution function CDF, the probability density function PDF, and the cumulative distribution function CDF are used to describe the probabilities associated with a continuous random variable. The continuous random variable formulae for these functions are, let us discuss. The probability density function of a continuous random variable can be defined as a function that gives the probability that the value of the random variable will fall between a range of values that we have to see here. Let x be the continuous random variable. Then the formula for the probability distribution function of f of x can be defined as f of x is equal to derivative of f of x by dx. It is f dash dx. Here, what is the difference between small f of x and capital F of x? Small f of x is the total value. It gives the total value of that cumulative probability density function. It is here capital F of x gives the functional value locally, where capital F of x is the cumulative distribution function. That's why we have to see the difference between probability density function and cumulative distribution function. So the here capital F of x denotes the cumulative distribution function. For the PDF, probability distribution function of continuous random variable, to be valid, it must satisfy the following conditions. So for PDF, if it is valid, it has to satisfy these conditions. Integral minus infinity to infinity f of x dx should be 1. This means that the total area under the graph of the PDF must be equal to 1, like this. This entire area should become 1. The PDF must be equal to 1. And one more condition is, it should be positive, that f of x is greater than or equal to 0. This implies that the probability density function of a continuous random variable cannot be negative. It is always positive. These two conditions are very, very important. What is the first condition? Integral minus infinity to infinity f of x dx is 1. And what is the second condition? f of x is always positive. It cannot be negative. Now let us see and discuss the graph of probability density function. Here, let us see x-axis. Let us take 2 points A and B on x-axis. Now, this y-axis represents f of x. Now, the area surrounded by x is equal to A, x is equal to B, and f of x and x-axis is the shaded part, this. Whatever I am showing here, this is. So, this shaded part can be probabilistically represented as P of A less than or equal to X, and it is going up to B less than or equal to B. So this area is P of A less than or equal to X less than or equal to B. Graphically we can represent. Now the cumulative distribution function of continuous random variable. The cumulative distribution function of a continuous random variable can be determined by integrating the probability density function, as we discussed earlier. So, it can be defined as the probability that the random variable x will take on a value that is lesser than or equal to a particular value x. The formula for the CDF of a continuous random variable evaluated between 2 points A and B is given below. Probability of A less than X strictly less than or equal to B is equal to difference between capital F of B minus capital F of A. The difference between capital F of B and capital F of A. So it can be represented as integral A to B f of x dx. This is the key point. Now let us discuss mean and variance of continuous random variable. The mean and variance of a continuous random variable can be determined with the help of the probability density function of f of x. So let us see mean of continuous random variable. The mean of a continuous random variable can be defined as the weighted average value of the random variable x. Means what we are doing. Mean means suppose sigma f of x by number of values n. Mean means total sum of total number of values divided by number of the values. So the mean of a continuous random variable can be defined as the weighted average value of the random variable x. It is also known as expectation. I told you before. This mean is also known as expectation of the continuous random variable. So how to find the mean of the continuous random variable using this formula? Expectation E of x is equal to it is nothing but our mu. Mean is equal to integral minus infinity to infinity x into f of x dx. So to find expectation or mean of a continuous random variable, this is the formula. E of x is equal to mu is equal to integral minus infinity to infinity x into f of x dx. It helps to determine the dispersion in the distribution of the continuous random variable with respect to the mean. The formula is given as follows. Now let us see continuous random variable types. A continuous random variable is usually used to model situations that involve measurements. For example, the possible values of the temperature on any given day, as the temperature could be any real number in a given interval. Thus, a continuous random variable is required to describe it. Some important continuous random variables associated with certain probability distributions are given below. Uniform random variable we can discuss. A continuous random variable that is used to describe a uniform distribution is known as a uniform random variable. Such a distribution describes events that are equally likely to occur. The probability distribution function PDF of a uniform random variable can be discussed as follows. Let us see this uniform random variable. Here on x-axis we are taking some points A and B. This y-axis represents our function f of x. Here we are taking the value exactly equal to b minus a length on y-axis. This point is 1 by b minus a. Then they are measuring the height at the level of 1 by b minus a. Now let us see normal random variable. A continuous random variable that is used to model a normal distribution is known as a normal random variable. If the parameters of a normal distribution are given as x tending to n of mu, mu means our mean, comma sigma 2. Then the formula for the probability distribution function is given as f of x is equal to 1 by sigma into square root of 2 pi into e to the power minus 1 by 2 into x minus mu whole square, x minus mu by sigma whole square. This gives us for the formula for the PDF, where mu represents mean, sigma represents standard deviation, sigma square is variance. That's why variance is equal to square of standard deviation. Variance is equal to square of standard deviation. Hence, standard deviation is equal to square root of plus or minus square root of variance. A normal distribution where mu is equal to 0 and variance sigma square is 1 is known as a standard normal distribution. A normal distribution where mu is equal to 0 and variance is equal to 1 is known as a standard normal distribution. Thus, a standard normal random variable is a continuous random variable that is used to model a standard normal distribution. The probability distribution function formula is as follows. See, if we see the normal distribution variable, mu is equal to 0 and sigma square mu is equal to 0 and sigma square is equal to 1. So, here we are discussing about mu plus or minus sigma. Then that graph appears like this. Now let us see exponential random variable e to the power. What is exponential? These exponential distributions are continuous probability distributions that model processes where a certain number of events occur continuously at a constant average rate lambda greater than or equal to 0. Here, thus, a continuous random variable used to describe such a distribution is called an exponential random variable. The probability distribution function PDF is given like this. X-axis, y-axis, and y-axis of our function is there. That curve is coming like this. This comes under standard distribution. But in this, it goes to exponential like this. That's why this is exponential random variable curve. Continuous random variable versus discrete random variable means now we are going to discuss the main differences between continuous random variable and discrete random variable. Both discrete and continuous random variables are used to model a random phenomenon. In both, we will visualize, we will see, we will discuss a random phenomenon. The differences between a continuous random variable and discrete random variable we can categorize and analyze like this. Let us see a continuous random variable and discrete random variable. The main difference in these two is while we see in continuous random variable, the value of a continuous random variable falls between a range of values in a range or an interval. While in discrete random variable, the value of a discrete random variable is an exact value, some numerical value we discussed earlier. While in continuous random variable, the probability density function is associated with a continuous random variable. Whereas in discrete random variable, the probability mass function is used to describe a discrete random variable. If we see the third difference, a continuous random variable can take on an infinite number of values. Key point. Because it is lying in a range, it is lying in a interval. That's why infinite number of values occur here. Whereas in a discrete random variable, such a variable can take a finite number of distinct values. These are the main differences. If we see the fourth difference, mean of continuous random variable is E of x is equal to integral minus infinity to infinity x into f of x dx, where in a discrete random variable, the mean of discrete random variable is E of x is equal to sigma x into P of x is equal to x, where P of x is equal to x is the probability mass function. Here we are not taking integration because it gives a specific numerical value, exact value. These are the main differences between discrete and continuous random variables. Let us see some important note on continuous random variable. A continuous random variable is a variable that is used to model continuous data, and its value falls between an interval of values, range, an interval of values. The probability density function PDF of a continuous random variable is given as small f of x is equal to derivative of capital F of x dx. It is f dash dx. So, the cumulative distribution function is given by P of A strictly less than x less than or equal to b is equal to capital F of b minus capital F of a. It is nothing but integral f of x dx. It gives us area. One more thing, uniform random variable, exponential random variable, normal random variable, and standard normal random variable, all are examples of continuous random variables. So what are the examples of continuous random variable? Exponential random variable, uniform random variable, normal random variable, standard normal random variable. All these come under examples of continuous random variables. Now let us see some examples of continuous variable. Continuous variables would take forever to count. There is no end. In fact, we would get to forever and never finish counting them. For example, take an ace. How do you count? We cannot count ace. Why? Because it would literally take forever. Second to second your ace counts. It increases. For example, it could be 37 years, 9 months, 6 days, 5 hours, 4 seconds, 5 milliseconds, 6 nanoseconds, 77 picoseconds, and so on. That's why countless. We cannot count this. Minute, second to second, it varies on. Now let us see example of a discrete and continuous random variable. For example, if x is equal to the number of miles to the nearest mile you drive to work, then x is a discrete random variable. You count the miles. If x is the distance you drive to work, then you measure values of x, and x is a continuous random variable. Let us see example of a continuous random variable. A continuous random variable is one which takes an infinite number of possible values. Continuous random variables are usually measurements. Examples include height, weight, the amount of sugar in an or else the time required to run a mile. Here, height, weight, the amount of sugar, like that, all these are examples of continuous random variables. A discrete variable is a variable that takes on distinct countable values. Distinct countable values. Now let us see the definition of variable. A continuous variable is a variable that takes on any value within a range, and the number of possible values within that range is infinite. Main difference. So here what we are going to discuss and what we are going to tell them is to discuss the main and important points and main and important differences between a discrete random variable and a continuous random variable. Discrete random variable always gives a definite value in some distinct possible countable values, whereas the continuous variable, it is a variable that takes on any value within a range, and the number of possible values within that range is infinite. So as we discuss all this, the discrete and continuous random variables, discrete random variable is specific to a continuous to a particular number, and continuous random variable is specific to some range. It is it is contemporary to some particular interval. So why age comes under continuous variable? Previously, as I discussed this matter, that at that time my age is different. Now, if my count, if my age is counted, it is definitely differ than previous one. It is going on. It could be some 45 years, some 8 months, 4 days, 3 hours, 5 seconds, 6 milliseconds, 7 nanoseconds, 89 picoseconds, and so on. Endless, continuous. So, once again, let us see the probability density function of a continuous random variable is nothing but small f of x is equal to derivative of capital F of x, some f dash x. So, the cumulative distribution function is a p of a less than x less than or equal to b is the difference between capital F of b and capital F of a. It is integral f of x dx. So, the uniform random variable, exponential random variable, normal random variable, and standard normal random variable all are examples of continuous random variables. So, altogether, overall, let us discuss once again the main differences between continuous random variable and discrete random variable. In continuous random variable, the value of a continuous random variable falls between a range of values. Means it falls between an interval, some open interval a comma b, how many values will be there in open interval a comma b? Infinite number of values will be there. Any value it may take. That's why it is continuous function. This variable is continuous random variable. While we discuss in discrete random variable, the value of a discrete random variable is an exact value. Why? While we flip a coin, the probability to come head upwards is 50%. Its numerical value is 1 by 2. Fixed. Specific numerical value 1 by 2. That is the main difference between there and here. While we discuss one more difference in these two variables, the probability density function is associated with a continuous random variable in continuous aspect, while the probability mass function, we say continuous density function in continuous random variables and probability mass function in discrete random variables. Same the function is there. That function is being named as probability density function in continuous random variables, and it is calling as probability mass function PMS in discrete random variable. Same function f of x. That f of x is being called the probability mass function PMF in a discrete random variable, probability density function PDF in a continuous random variable. PDF in continuous random variable. PMF, probability mass function in discrete random variable. That is the difference. Now let us see, a continuous random variable can take on an infinite number of values because it is lying in an interval. It is lying in a range. That's why it take infinite number of values. While we discuss in a discrete random variable, such a variable can take on a finite number of distinct values. As we discussed for flipping a coin, 1 by 2 comma 1 by 2. Coming head, half of the chance. Coming tail, half of the chance. If we come to the point of mean, in both, mean of a continuous random variable is defined as E of x is equal to integral minus infinity to infinity x into f of x dx. We have discussed earlier. Why in a discrete random variable, that integration we don't take because here a specific numerical value is there for discrete. The mean of a discrete random variable E of x is equal to sigma we use. Sigma x into P of x is equal to x, where P of x is equal to x is the probability mass function. So these are the main variable differences between the given random variables, continuous and discrete random variables. So both discrete and continuous random variables are used to model a random phenomenon. Now, a exponential random variable, as we discussed earlier, here its parameter lambda is always positive. The exponential distributions are continuous probability distributions. That's why lambda is always positive. That model processes where a certain number of events occur continuously at a constant average rate lambda greater than 0. Thus, A continuous random variable used to describe such a distribution called an exponential random variable. So its PDF we can show like this. So when do we say a normal distribution is a standard normal distribution? Two conditions are there. Mean should be 0. Variance sigma square is 1. These are the two conditions. When a normal distribution is taken, if its mean mu is equal to 0 and its variance sigma square is 1, then we say that normal distribution is a standard normal distribution. Thus, a standard normal distribution variable is a continuous random variable that is used to model a standard normal distribution. The PDF formula can be described as f of x is equal to 1 by sigma into square root of 2 pi into e to the power of minus x minus mu whole square by sigma. So, the parameters of the normal distribution are given x mapping to n mu to sigma mu comma sigma. Then the formula for the PDF is given as f of x is equal to 1 by sigma into square root of 2 pi into e to the power minus 1 by 2 into x minus mu by sigma whole square. Here mu is mean, sigma is standard deviation, and sigma square is variance. So variance is equal to square of standard deviation. So standard deviation is equal to plus or minus square root of variance. Once again, let us see uniform random variable. As well, it can be understood from this graph. Uniformly we are taking on both x-axis and y-axis. Normal random variable, a continuous random variable that is used to model a normal distribution is known as normal random variable. So, the continuous random variable types. Once again, let us see. A continuous random variable is usually used to model situations that involve measurements. For example, the possible values of the temperature on any given day, as the temperature could be any real number in a given interval. Thus, a continuous random variable is required to describe it. Some important continuous random variables associated with certain probability distributions, and all these things we can discuss like this. Uniform random variable. What is uniform random variable? It has to maintain a uniformity between a group to group. A continuous random variable that is used to describe a uniform distribution is known as a uniform random variable. Such a distribution describes events that are equally likely to occur. The PDF of a uniform random variable already we have discussed earlier. Once again, let us see mean of continuous random variable. The mean of a continuous random variable can be defined as the weighted average value of the random variable x. It is also known as the expectation of the continuous random variable. So the formula can be taken like this. E of x, expectation of random variable x, is equal to mu is equal to integral minus infinity to infinity x into f of x dx. It helps to determine the dispersion in the distribution of the continuous random variable with respect to the mean. So, once let us analyze graph of probability density function. On x-axis, we are taking the value x is equal to a, x is equal to b, and this is our graph f of x. So, under x-axis, and x is equal to a, and x is equal to b, and graph function f of x, the area lying between them is whatever I am showing here is this one. This can be typically shown as P of a less than or equal to x less than or equal to b. So this area comes as a probability density functional area. This is the CDF of continuous random variable. The cumulative distribution function of a continuous random variable can be determined by integrating the probability density function. So here you can see f of x is equal to derivative of f of x dx, it is f dash dx, where f of x is the cumulative distribution function. For the PDF of a continuous random variable to be valid, it must satisfy the following conditions. Earlier I told you, integral minus infinity to infinity f of x dx is equal to 1. The entire area should be 1. This means that the total area under the graph of the PDF must be equal to 1. The second condition is f of x is always positive, greater than or equal to 0. It cannot be negative. This implies that the probability density function of a continuous random variable cannot be negative. Once again, let us see the continuous random variable formulae. The probability density function and the cumulative distribution function, they are used to describe the probabilities associated with a continuous random variable. The continuous random variable formulae for these two functions already we have discussed earlier. The probability distribution function of continuous random variable, the probability density function of a continuous random variable can be defined as a function that gives the probability that the value of the random variable will fall between a range of values. So, the cumulative distribution function and the probability distribution function are used to describe the characteristics of a continuous random variable. Continuous random variable, let us take one example. Suppose the probability density function of a continuous random variable x is defined as some 4x cube. Here the function f of x is equal to 4x cube. Now let us take its integration. The probability that x takes on a value between 1 by 2 and 1 needs to be determined. This can be done by integrating 4x cube between the limits 1 by 2 and 1. It is upper limit minus lower limit. Upper limit is 1, lower limit is 1 by 16, so it is 15 by 16. So once again, come to a concrete idea about what is continuous random variable and what is discrete random variable. A continuous random variable and a discrete random variable are the two types of random variables. A random variable is a variable whose value depends on all the possible outcomes of an experiment. A continuous random variable is defined over a range of values, while a discrete random variable is defined at an exact value. So continuous random variable definition, if we see, a continuous random variable can be defined as a random variable that can take on an infinite number of possible values. Due to this, the probability that a continuous random variable will take on an exact value is 0 because it lies in a group or interval. So continuous random variable is a random variable that can take on a continuum of values. In other words, a random variable is said to be continuous if it assumes a value that falls between a particular interval. Continuous random variables are used to denote measurements such as height, weight, time, etc. The area under a density curve is used to represent a continuous random variable. So till now we have discussed so many features of this continuous random variable, its mean, variance, types, and associated examples. So many we have discussed here. So by concluding all these, what can we say? A discrete random variable finally gives a specific numerical value, whereas a continuous random variable gives a value in a range, in an interval. That is the main feature, main difference between discrete random variable and continuous random variable. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.